In this session, let us learn about machine learning polynomial regression. Polynomial regression. If your data points clearly will not fit a linear regression, a straight line through all data points, it might be ideal for polynomial regressions. Polynomial regression, like linear regression, use the relationship between the variables x and y to find the best way to draw a line through the data points. How does it work? Python has methods for finding a relationship between data points and to draw a line of polynomial regression. We will show how to use these methods instead of going through the mathematical formula. In the example below, we have registered 18 cars as they were passing a certain toll booth. We have registered the car speed and the time of a day, however the passing occurred. The x-axis represents the hour of the day and the y-axis represents the speed. See example, start by drawing a scatter plot. See, by writing and executing this code, the result is this, some scatter plots. Import NumPy and Matplotlib, then draw the line of polynomial regression. See, by importing and executing this code, the result returns this. See, the polynomial line was drawn. Example explained. Import the modules you need. You can learn about the NumPy module in your NumPy tutorial. You can learn about the SciPy module in your SciPy tutorial. See, import NumPy, import Matplotlib, pyplot as PLT. Create the arrays that represent the values of the x and y axis. See, you have given some values. NumPy has a method that lets us make a polynomial module. My model is equal to numpy.polyfit xy3. See, then specify how the line will display. We start at position 1 and end at position 22. See here, my line is equal to numpy.linespace 1, 22 and 100. Draw the original scatter plot, plt.scatter xy. Draw the line of polynomial regression. See, plt.plot my line, my model, my line. Display the diagram, plt show. R squared. It is important to know how will the relationship between the values of the x and y axis is. If there are no relationship, the polynomial regression cannot be used to predict anything. The relationship is measured with a value called the R squared. The R squared value ranges from 0 to 1, and where 0 means no relationship and 1 means 100% related. Python and the Sklearn module will compute this value for you. All you have to do is feed it with the x and y arrays. See example, how well does my data fit in a polynomial regression. See, by writing and executing this code, the result is 0.94 shows that there is a very good relationship. The result 0.94 shows that there is a very good relationship, and we can use the polynomial regression in future predictions. Predict future values. Now we can use the information we have gathered to predict future values. Example, let us try to predict the future of a car that passes the toll booth at around 1:07 p.m. To do so, we need the same module array from the example above. My module is equal to numpy.poly 1d numpy.polyfit xy3. See the example, predict the speed of a car passing at 1:07 p.m. Import NumPy. See here, the result, the example predicted a speed to be 88.87, which we also could read from the diagram. See the diagram. Bad fit. Let us create an example where polynomial regression would not be the best method to predict future values. These values for the x and y axis should result in a very bad fit for polynomial regression. See, by writing and executing this code, see, this is a bad fit. The result returns this and the R squared value. Example, you should get a very low R squared value. By writing and executing this code, the result is 0.00995, indicates a very bad relationship and tells us that this data set is not suitable for polynomial regression. Okay friends, this is the end of part 9, machine learning polynomial regressions. In next video, let us learn about another topic, machine learning multiple regressions. If you like our program, please like, subscribe and press bell icon for our next part video updates. Thank you friends. Meet you in next video. All the best.